Problem number 8. The general expression in this one is much difficult, I would say, because you need to figure out some kind of alternative form for the general case. So let's try to do it like slowly, one step at a time. So we have 100 terms in this sum, and the general term is the following. Let me use n. That's like, let me write this in the opposite order. n4 plus n squared plus 1. That's the general form. So like 1 plus n squared. So square and then fourth order. So how do I simplify this? So the first step is to look at the denominator, though that's something, there is something happening. So let me write n4 plus n squared plus 1 as, so this is another common trick when you have like fourth degree. You can bring this expression to sum of the difference of squares as follows. If you write it as 2n squared plus 1 minus n squared, right? So this 2n squared minus n squared makes n squared, so that's good. And this one, this is square of n squared plus 1 minus n squared. Now we have difference of two squares. You can factorize the difference of two squares as a minus b, a plus b. So this expression can be rewritten as n squared plus 1 minus n squared plus 1 plus n. So we have factorization of this expression. So the factorization is the following: n squared plus n squared plus. So why do we need the factorization of n to the power 4 plus n squared plus 1? That's because we want to do the splitting of two fractions. The split, rewrite it as a difference of sum of two different fractions. So like we want to split it into two different fractions. So since we have the difference of these two numbers is 2n, I can rewrite the following. I can do the following expression. So let's do the difference here. N squared plus 1 minus n minus n squared plus 1 plus n. So if you do the common denominator of these two and then the difference, so that, what does it give? What does it give? This gives me n squared plus 1 plus n here, and then n squared plus 1 minus n. So this is still not there, so we need 1 over 2. So basically, if I do 1 over 2, I'll get the equality with this expression, and then here. So that's the idea. So you can verify this splitting of the fraction into two by yourself, but that's what we have. But the problem here is still there. So like we still have the problem. What's the problem? We have n here and then n here. So when we want to do the cancellation, like in the previous problems, we need like n minus 1 and like two different numbers, like n minus 1 and n2, like two consecutive numbers. So that's the next step that I'm going to do here. So let me remove this part. So like I'm not done with this expression basically. Let's look at this n squared plus 1 minus n. I can rewrite this expression as follows. If I write it as n minus 2n plus 1 plus n. So basically, we have minus n here, so this is minus 2n plus n. So that's like balances, all right. What if I write it like if I do, so this term is basically n minus 1 square, okay? And we have plus n. Let me write the plus n as follows: plus 1 plus n minus 1. So minus 1 and 1 gets cancelled. So in other words, if I use this equality, the general term becomes something like this. It's 1 over 2. The first fraction is the square of n minus 1 plus the n minus 1, right? Plus 1. And the next one is n squared plus n plus 1. So these two numbers have same form now. The square of a number, this number itself, and then plus 1. Square of a number plus 1. So that's what we have. Like so basically, if you simplify this expression, you'll get this one. And try to figure out how to get from here to here one more time. So, and in the end, so let me make it smaller. 1 second. Okay, make a space for myself. So, if I rewrite the initial expression, so we have this. It starts with n. The expression is n, but we have n minus 1. So all the expressions will have 1 over 2. So I will put this 1 over 2 in front of everything. And then we have like 1 over 0 squared plus 0 plus 1 minus. So this is the first term, okay? And what will be the second term? The second term is going to be 1 over 1 squared plus 1 minus 2 squared plus 2 plus 1. What will be the third term? The third term is going to be 1 over 2 squared plus 2 plus 1 minus 1 over 3 squared plus 3 plus 1. And so on. You have 100 terms. And then when you do the sum, you can see that this term and this term becomes 0, this one and this one becomes 0, and so on. Then in the end, you are left with the very first term, then the very last term, which is 100. So the result is going to be 1 over 2. So this is 1, 0 squared plus 0 plus 1 minus the last one is 100 squared plus 100 plus 1. Or in other words, this is 1 multiplied by 1 over 2. So this is zeros are 1. So 1 over 2 minus. This is like 10,101. If you multiply it by 2, it's like. So that's the almost. So like you do the subtraction, and that's the final result for this expression. So again, the idea was to rewrite the expression in this form, and then you'll get the canceling terms, alternating terms. So that's like basically called like do the alternating sums, and then things get canceled out.